start with the concept of strong and weak electrolytes. So I'll write strong electrolytes and I'll write here weak electrolytes. So we can compare them also while learning. Right? So now what is a strong electrolyte? Before that, let's understand what is an electrolyte. So I'll write it here in a different font. So what is an electrolyte? These are the compounds. When dissolved in water, they produce ions in their solutions. Okay. So compounds that when dissolved in water produce ions in their solutions. Okay. Now we need to know that the ions are free to move about and they also carry electric charge, okay, through the solution when an electric field is applied. And therefore such solutions are good conductors of electricity. So such solutions are good conductors of electricity. And why are they good conductors of electricity? Because of the conduction by ions in the solution. Okay. So now let's take an example and see. While understanding strong and weak electrolyte, we will also understand the concept of electrolyte. Okay. So what is strong electrolyte? These electrolytes are completely dissolved in, uh, completely converted into ions when they are dissolved in water. So this is important. Completely converted into ions. Okay, when dissolved in water. And what are the examples that can come about? So if you are asked the examples, just remember all ionic compounds. What are the examples of ionic compounds? Like sodium chloride NaCl, potassium chloride KCl, potassium nitrate KNO3. Also remember this compound ammonium chloride NH4Cl. So when you talk about sodium chloride, potassium chloride, you know that sodium is an alkali metal, potassium is an alkali metal. However, NH4Cl is a slightly different compound because NH4Cl is formed from ammonia and hydrogen chloride, NH3, ammonia and hydrogen chloride. Okay, so let's not go into the detail at this stage, but just remember this example of ammonium chloride when you talk about ionic compounds being strong electrolytes, because it might be asked in the exam. All right, and also some covalent compounds like HCl. Okay, so predominantly it is ionic compounds that are uh, categorized as strong electrolytes. However, some uh, covalent compound like HCl. So remember NH4Cl and HCl in this case. Okay, and we will write an equation that represents the formation of ions. Okay, and it is represented by a single arrow because almost all of the ions are almost the entire compound of strong electrolyte is converted into ions. How do we write it? Right now, if you take a case of NaCl, you are dissolving in water, you write it as aqueous, dot, and there is a single arrow, and it dissociates into Na plus sodium ions because you know sodium chloride is formed when sodium donates one electron to chlorine, and then sodium when donates one electron it becomes sodium ion and chlorine becomes chloride ion. So that is how they form sodium chloride. So when dissolved in water they separate into those ions. So sodium chloride aqueous plus, here it will be chloride minus aqueous. Remember something, that single arrow is there to denote that they are completely converted into ions. Okay. Similarly, we can take one more example also. Let us say HCl, hydrogen chloride, in the form of gas, and this gas is dissolved in water, which is H2O, and we write it as, whenever we write a liquid HCl, it will be H2O, and then we have H3O plus, which is hydronium ion, So H plus, which is proton plus H2O will give H3O plus chloride ion. And again note the single arrow that we have drawn to denote the dissociation of a strong electron. Agree? Now let's come to weak electrolyte. So I just draw a line to separate the two electrolytes. What is a weak electrolyte? Obviously, they are not completely converted into ions. So here you will write for weak electrolytes only partially ionized. Only partially ionized when dissolved in water. Okay, here it's complete for strong electrolytes, and for weak electrolytes only partially ionized. So what are the examples? So all ionic compounds come under strong electrolytes. So obviously many covalent compounds, they should come into your mind whenever you are understanding weak electrolytes. And what are some of the examples? Like acetic acid CH3COOH, then ammonium hydroxide NH4OH. Then if you remember this uh, aminobenzene, you can write C6H5NH2. But even if you don't remember, it's okay. Just focus on this compound if it's asked in uh, 1 mark questions. Now what happens, because it is only partially ionized, so when dissolved in water, they are in the form of partly molecular form. It is unionized molecular form, we call it unionized molecular form. Okay, and then some are converted into ions. Okay, now when it is partial conversion of the compound into ions, there will be dynamic equilibrium. Okay, so at any time after conversion also, some of the ions combine and form the molecules, and some of the molecules again go and form the ions. So this process of to and fro is continuous, and it is called dynamic equilibrium. And because it is equilibrium, we are representing the equation by reversible arrows, unlike a single arrow in strong electrolyte. So for example, if you take acetic acid case, CH3COOH, this is acetic acid and it is in a liquid form, plus you are dissolving it in water, so H2L, H2O, again in liquid form. Now note these reversible arrows to indicate the dynamic equilibrium. So it will convert into hydronium ions, which is H3O plus aqueous, and further into CH3COO minus, which is acetate ion aqueous. So note the reversible arrows. Okay. Now we need to understand one more concept here, which is nothing but degree of ionization of a weak electrolyte. So of a strong electrolyte, obviously it is totally converted into ions. So degree of ionization will be very equal to 1. So what is the degree of ionization of a weak electrolyte? We denote it by the symbol alpha. It's not a proportional sign, it is alpha. Now what is its definition? So it is defined as the fraction or percentage of total amount or concentration of the electrolyte that is present in the form of ions. So in general, degree of ionization, let's not write weak right now, of any electrolyte. Okay, that is alpha is defined as fraction or percentage of the total amount or concentration of the electrolyte that is present in the form of ions. So for a strong electrolyte, this value of alpha is 1 because there is a total conversion of compound into its respective ions. Let's say for a weak electrolyte like CH3COOH, whatever we just now discussed, when it is dissolved in water, there is a dynamic equilibrium between the ionic form acetate ion plus hydronium ion, right? Now here let us say let let 30% get converted into ionic form. Okay, then what we have is, uh, if suppose this concentration, or let's say this is in liquid form, so let's say I'm taking uh, 10 ml of CH3COOH. So 30% gets converted into ion, means around 3.3 ml is present in the form of ions. Okay, and when we talk about concentration, we will say how many moles per liter. Okay, so just understand 3.3 ml of this CH3COOH is converted into iron, so remaining is 6.7 ml in the form of CH3COOH, and the remaining is converted into ions. So what do we write? Alpha is 30% or zero point 0.3 in this case. Okay, now when we further discuss the concepts of this ionization constant, we will be able to appreciate this degree of ionization. So let's see that in the next.